Have you ever wondered what secrets the sun holds? Welcome, fellow cosmic explorers, to an adventure that promises to illuminate the mysteries of our very own star. Today, we're going on an interstellar journey to discover 10 fascinating facts about the sun. We'll dive into its fiery heart, explore its colossal size, and uncover its astounding power. Expect to be dazzled, humbled, and left awestruck by the sheer magnificence of our solar system's cornerstone. So, buckle up and prepare to embark on a journey to our very own star. Did you know that the sun is not just any star but a special one? Sure, it's a star, but it's not just any star on the block. It's a G-type main sequence star, or as we like to call it in the celestial neighborhood, a G-dwarf star. Now don't let the name fool you, there's nothing small or insignificant about our sun. This stellar classification means that our sun is in its prime, burning brightly and stably. It's the perfect balance, not too hot and not too cold. Its composition? Mostly hydrogen and helium, the two lightest elements in the universe. The sun is like a giant cosmic pressure cooker, fusing hydrogen atoms into helium through nuclear fusion, releasing vast amounts of energy in the process. So next time you look up at the sky, remember our sun isn't just any star, it's a G-star. Now that's a star with some serious street cred in the universe. You think the Earth is big? You haven't seen anything yet. Let's put things into perspective. Imagine, if you will, a million Earths. Now picture all of those Earths fitting inside one giant sphere. That's how gargantuan our sun is. It's so enormous, in fact, that it makes up about 99.86% of the total mass of our solar system. But let's not stop there. Picture yourself standing on the surface of the sun. Not that you'd want to. It's a toasty 5,500 degrees Celsius. You'd find that the sun's diameter is about 109 times that of Earth's. It's mind-boggling to comprehend, isn't it? The sun's colossal size is a testament to its incredible power and the vital role it plays in our solar system. So, next time you're feeling a bit too big for your boots, remember this. In the grand cosmic scale, our Earth is but a tiny speck compared to the sun. Ever wondered why we don't just float off into space? Well, the answer lies in the immense gravitational pull of our very own star, the sun. This fiery ball of gas in the center of our solar system has a gravitational force so strong that it keeps not just our Earth but all the other planets in check, holding them in their respective orbits. Imagine the sun as the charismatic host of a cosmic party where all the planets are guests, swirling around in a dance choreographed by gravity. It's a delicate balance, a gravitational tug-of-war, if you will. The sun pulls the planets towards it while their momentum tries to pull them away. But the sun's gravity is the reigning champ, keeping everything in perfect harmony. So next time you're enjoying a walk on a sunny day, remember, it's not just the Earth's gravity keeping your feet on the ground. So we have the sun to thank for our feet staying firmly on the ground. Feeling hot? You can blame our sun for that. Our sun is not just a bright spot in the sky, it's an enormous powerhouse that produces heat and light, the lifeblood of our planet. It's like the world's biggest bonfire, burning away 24/7, 365 days a year. But instead of wood or coal, it burns hydrogen through a process called nuclear fusion. This fusion generates an immense amount of energy, which travels millions of miles to reach us as heat and light. Without it, Earth would be a dark, frozen wasteland. But thanks to the sun, we have warm summers, light to see by, and energy for plants to grow. It's like the sun is throwing the world's longest, most massive barbecue, and we're all invited. And while it's easy to complain about the heat in the middle of summer, remember that without it, life as we know it wouldn't exist. So while you're enjoying your summer vacation, remember to thank the sun for those warm rays. Our sun is a seasoned veteran in the cosmic timeline. Born around 4.5 billion years ago, our sun is in its prime, akin to a person in their 30s or 40s. It's a middle-aged star halfway through its 10 billion year lifespan. So, how do stars like our sun live and die? Well, they're born from clouds of dust and gas growing over millions of years. In their prime, they fuse hydrogen to create helium in a process called nuclear fusion, releasing light and heat. That's the sunshine we enjoy on Earth. As stars age, they start to run out of hydrogen. They expand, becoming red giants. Eventually, the helium starts to fuse into heavier elements until the star can't sustain the process. It then collapses and throws off its outer layers, leaving behind a dense core. So, our sun is middle-aged in star years and still has a long way to go. Ever thought about taking a trip to the sun? Better pack for a long journey. You see, the sun isn't just around the corner, it's astonishingly far away. The average distance from Earth to the sun is what we call an astronomical unit. It's a term astronomers use to make cosmic measurements more manageable. Now try to wrap your head around this. One astronomical unit is approximately 93 million miles. Yes, you heard it right, 93 million. That's a road trip that would make even the most seasoned traveler blanch. To put it in perspective, if you were to drive at a steady speed of 60 miles per hour, 24 hours a day, it would take you more than 176 years to reach the sun. Yes, you'd be a skeleton by the time you made it. It's a long trip, about 93 million miles. Better start walking now. Our sun is not just sitting still, it's doing a cosmic dance. Yes, you heard it right. The sun, like Earth, spins or rotates on its axis. But there's a twist. The sun doesn't rotate like Earth, where every point from the North Pole to the South Pole takes 24 hours to complete a rotation. The sun's rotation varies depending on where you look. At the sun's equator, it takes about 25 days to complete one full rotation. But as we move towards the poles, the rotation slows down. The sun's poles take a lengthy 36 days to make one full turn. This phenomenon, known as differential rotation, is due to the sun's gaseous nature. Unlike a solid body, different parts of the sun can move at different speeds. So the next time you're watching a sunset, think about this. As Earth spins, the sun is also twirling on its axis, albeit at a different pace. So while you're spinning around on Earth, remember the sun is dancing in space too. Our sun is not just a ball of fire, it's a firework display. That's right, folks, our very own sun is quite the performer, and solar flares are its grand finale. These dramatic eruptions are essentially gigantic explosions on the sun's surface, releasing energy equivalent to millions of hydrogen bombs. But what do these solar flares mean for us on Earth? Aside from the occasional disruption to our satellite communications, they're responsible for one of nature's most breathtaking phenomena, the northern and southern lights. Imagine, particles from the sun, traveling 93 million miles interacting with our planet's magnetic field to create a celestial ballet of lights. These spectacular displays, known as aurora borealis in the north and aurora australis in the south, are the Earth's way of transforming solar energy into a visual feast. So next time you see those beautiful lights in the sky, remember, it's the sun putting on a show. What does the future hold for our sun? Let's find out. Our sun, the glowing heart of our solar system, isn't immortal. In about 5 billion years it will bid goodbye to its middle-aged phase, an era marked by the fusion of hydrogen into helium. As it exhausts its hydrogen fuel, our sun will enter a new stage of life. It will expand and transform into a red giant. This phase will be anything but quiet. The sun's outer layers will expand, devouring Mercury, Venus, and perhaps even Earth. But don't worry, this won't happen for another 5 billion years or so. Our sun, in its red giant phase, will shine 100 times brighter than it does now. It will be a sight to behold, a fiery red spectacle in the sky. Eventually the sun will shed its outer layers, releasing a planetary nebula, a shell of gas and dust. What will remain is the sun's core, a white dwarf. This white dwarf will glow with the leftover heat from its previous life, slowly cooling and fading away over billions of years. So, the sun's future is a tale of transformation, from a middle-aged star to a red giant and then to a white dwarf. It's a cycle that mirrors the life and death of stars throughout the universe. So while our sun has a few billion years left, its future is set in the stars. So, what have we learned about our sun today? Well, first and foremost, we've established that our sun is not just another star. It's the colossal powerhouse of our solar system. Its massive size, roughly 1 million times that of Earth, and its intense gravity, are what keep our planetary family in check. We've also discovered that the sun's heat and light are the result of nuclear fusion, a process that has been ongoing for about 4.5 billion years. But here's the catch, it's halfway through its lifespan, and in about 5 billion years it will swell into a red giant. We've learned about the sun's rotation, its distance from Earth, and the spectacular, yet potentially disruptive solar flares. And let's not forget that our future is intertwined with the sun's future. As we wrap up our cosmic journey, remember, our sun is more than just a bright light in the sky, it's the heart of our solar system.